Hey guys, in our last set of notes in this section, we are going to talk about sectors of circles. And sectors of circles are just parts of a circle. So first we need to know what the area of a circle is. So our formula for area of a circle is pi r squared. When we're talking area, it's everything inside. So all of that shaded piece that you see. So some things you'll be asked to do are to find the area. We're given a radius of 4.2, so we're going to use A equals pi r squared. So we're looking for area. We have pi, and then we have 4.2 quantity squared. So to find this area, if we do 4.2 squared, I get 17.64. Pi would be my exact answer, and that would be meters squared. If it asks for exact, if it asks for approximate, I'd go ahead and multiply by pi. So 17.64 times pi would be 55.42 meters squared. Either of those would be acceptable answers depending on what the question is asking. All right, for this one, it's asking for the diameter and you know the area. We don't have an area formula that uses diameter, so we're still going to use pi r squared here. So if I know the area is 201, I'm going to replace area with 201. I'm going to put pi r squared. So I'm going to divide both sides by pi. And I end up with 201 divided by pi is approximately 63.98 is approximately radius squared. Now to get radius by itself, we need to take the square root on both sides. So the square root of 63.98 is about 8, and that would be inches. But it wants to know the diameter. So diameter then would be all the way across the circle, so it would be about 16 inches. Okay, so here's where we get into area of a sector. And a sector is just kind of like a pie piece of the circle. We talked about the arc length of AB in our last lesson, but in this case we have the sector of the circle, so that whole shaded area. Now to set it up, it's going to look very similar to what we set up with the arc length. We have the degree measure over 360 is equal to the area of the sector over the total area of the circle. So we can say of circle if we want. So just like before, the top part is the part of the circle, the top of those ratios, the bottom is the whole circle. Left is talking degrees, right is talking area this time. So we can set this up in example 2. We have the degree measure of 63 over our total degrees of 360. That's equal to the area of the sector. We don't know. That's what we want to find. So we can say, we can call it X, we can call it the area of the sector, whatever we want, over the total area of the circle. So to find the area of the circle, if we don't know it, we use pi r squared. In this case, our radius is 5. So I'm going to do 25 pi times 63 here. So I'm just going to do 25 times 63, and I get 1575 pi is equal to 360x. So I'm leaving the pi there just so I'm not dealing with decimals. I'll multiply it in there on this final step. So 1575 pi over 360. And when I do that, I get about 13.74. So the area of the sector is about 13.74, and that we don't have units, so we'll call it units squared. Alright, let's look at another one. It says use the diagram to find the area of circle C. So I have the degree measure. I know the total degrees. I know the area of the sector is 22. I want the area of the circle. So I'm going to call that A. So notice we don't have pi in there. We don't have to do anything along those lines. We're just cross multiplying. So 45A is equal to 22 times 360, which is 7,920. Divide by 45 on both sides. So A is equal to 176, and our label here would be meters squared. Alright, last question doesn't really have to do with area of a sector so much. It kind of goes along those same lines when we get into cutting these pieces apart. But it's saying we need to cut out a piece of this board. So we have a rectangular board. We need to find the area of the rectangle. And we need to cut out, and I'm going to break this apart. I have here a square, it looks like. So subtract area of a square. And then I also have half of a circle. So minus half the area of a circle. So that's how my setup works. So first I'm going to find the area of the rectangle. So I see that it is 11 by 7. And then the area of the square is 3 by 3, or 3 squared. And then I have half times pi. Now my radius here is not 3, it's actually 1.5 squared. So I have 77 minus 9 minus, we have 1.5 squared times 1/2. Times pi, and we get about 3.5. So now I can do 77 minus 9 minus 3.5, and I get about 64.5. And since we're talking area, we have inches squared. Now, it says to the nearest square inch. So, had I actually taken this out a little bit more, I think it would have rounded down, but this would actually round up to 65 inches squared. So depending on how you rounded, you may have ended up with 64 square inches instead. If you have questions, come in and see me. I will see you in class.